mode.
Greetings, everyone. This is Kevin Schofield. I'm the Senior Product Manager for Geomagic. Today we're going to do a webinar that's going to go through Geomagic Design Direct, which is one of our flagship products for reverse engineering. And it's a product that does an excellent job of converting scan data from three-dimensional scanners into usable CAD geometry that you can then go and create drawings from or assemblies or do renderings of to support any of your manufacturing or archival purposes. So first, we're going to go through a couple of quick slides to orient you with both 3D systems and Geomagic's role within 3D systems. So the vision of Geomagic within the 3D systems ecosystem is to essentially reinvent the engineering desktop. We want to empower users to design and make anything, anywhere, by anyone with any complexity. We create a variety of products from pure CAD modeling solutions to hybrid scan data, CAD modeling solutions, all the way into inspection and freeform organic shape modeling. So Geomagic has a wide variety of software offerings that are now part of the 3D Systems brand that we feel adds a lot of value to the end users out there. And Geomagic, just to clarify, is one of the 3D Systems brands, so we fit in nicely with a lot of the other products that are part of the 3D Systems portfolio, including the healthcare, quick parts for rapid part production, the professional line of ProJet printers, and the Cubify line of consumer-oriented printers. So we are one of the many components of 3D Systems, and we're the largest software provider within 3D Systems. So many of the software products that you have known from Geomagic, Rapidform, Libre, Sensible, some of these former companies that are now all part of the Geomagic Solutions umbrella. And so this is our role within 3D Systems, is to provide software solutions to support all of these other products and product lines. Let's dive a little deeper into what we're talking about today. So one way to orient you is that a lot of the design tools that we make center on some of the aspects you see at the top, things like voxels, CAD, haptics, scan, modeling, print. These are buzzwords that we use around the office to describe some of the products that we create. So anything from a haptic-driven virtual clay to scan to print workflows to creating pure CAD models and drawings. These are all the capabilities that are within the mantra of what Geomagic Solutions is all about. And what we're going to do today is we're going to concentrate on Geomagic Design Direct, and I'll explain this particular product. For those of you that might have been aware, the product was formerly known as Geomagic Spark when it was introduced back in January of this year. Has a relatively short lifespan so far. It's only been on the market for about 7 or 8 months. But as part of the rebranding effort, we changed the name to Geomagic Design Direct. And really, the purpose of this product is it's a very fast, simple CAD modeling tool when dealing with 3D scan data. So as you'll see in a few minutes, we'll spend the majority of the webinar in a live demonstration that I'll give you. And primarily, they're designed around a very robust direct modeling package from SpaceClaim. SpaceClaim is the leading direct modeling software, and direct modeling is a flavor of CAD modeling that involves a simplistic, intuitive push-pull mechanism for modeling. So if you have a face and you want to move it to change the offset, you just click it and drag it. There's no parameters to input. It's as powerful as parametric modeling. It's just a different technique. It's a different way of getting to the same result. So today I'll share some tips and some tricks with you on how direct modeling works and then how we interact with it to go from that really rough scan data like you see on this purple part to the orange CAD model on the right. So I'll give you some examples and we'll go through a couple of different little gallery images of parts that you can work on. One thing that we like is that this is an all-in-one solution. You can do not just 3D CAD modeling, you can also do 2D detailed drawings, actually creating full dimension drawings from it. It handles full assembly modeling. As you see on the right, you can see that you can have multiple parts in your assembly from a single scan. You also get a free library of parts and trace parts that's provided by SpaceClaim. And we also have a rendering solution from KeyShot that we're offering that's part of this package as well at no additional cost. Just to give you an idea of the types of objects or shapes that you can that are applicable to this, essentially very kind of mechanical shapes with some surfacing elements to it that you could loft or sweep. So like this little part here has a nice blend that fades out on the end. There's a perfect little shape to be done inside of Design Direct. Here's an element that blends a little bit of organic and mechanical together, so that's a scan of a foosball table player. And the goal here was to reverse engineer the lower portion. So one thing that this product does not do would be complex surfacing of the upper body or head portion. But you can marry that with any of the other products, like the voxel product called Freeform or Clay Tools, if you wanted to be able to blend the two together. So here's just a color, again, just a gallery of some simple parts, things that are fairly easy. Next part here is this little roller gear is actually one that I'll do live in a few minutes. It's a good example of taking very rough, incomplete data and creating CAD models rapidly. Another example of, this is a pretty good consumer example of a plastic piece that was a retaining ring for some landscape lighting that had broken. And we scanned it and were able to create a CAD model and print a replacement, or print a copy that this homeowner could use so that he wouldn't have to replace the entire light. He just needed to replace this plastic retaining ring, which is a fairly cheap, inexpensive part, but he had trouble finding them on the open market. So that was a fun little example of how you don't need complete scan data because you can interpolate simply as a 360-degree part. So all you need is a portion of the scan to be able to replicate the whole part. And then lastly, just a few other kind of simplistic examples of the types of extruded, revolved, flat, cone, cylinders, and things like that you can create. A little bit more complex case here, a part that has some offset to it. And you can see that purple scan data on the right has all the imperfections that you would expect with the tooling marks and some areas, the little plastic nubs that were scanned. Of course, you don't need those. Those aren't incorporated into the actual design, so you ignore them, but all the other pieces you want can be fairly easily extracted from the scan data. All right, so what better way to show you than to just dive in. Let's do a demonstration, and I'll walk through several different parts. I'm going to mix in a video towards the end that kind of shows some new capabilities we have, not just with scanning, but with a hard probe device as well. So I'm going to flip over here to our Design Direct window and let you orient for a second. So this is what the interface looks like. If you're familiar with the product called Space Claim, it will look almost identical to it, with the exception that we've added some tools and some toolbars that are specific and unique to the Geomagic solution. So this is our tools that help us handle point cloud data, scan and connect directly to scanning devices, and then ultimately generate and extract solid geometry. So what we're going to do to start is we're actually going to load in a fairly simplistic model. It's a simple steel reference block that we have around here. And I thought this would be good to orient you to how the process works from going from scan data clear on through to creating solid geometry. Now, when we load this, we'll see this is about 414,000 points. So again, most CAD systems don't support loading a point cloud, with some exceptions. So this is a unique capability, is the ability to load point clouds. And this is a fairly small point cloud at only not even 500,000. You can load point clouds ranging up to 10 to 20 million points. And what we do is, when we load those in, you don't necessarily need all those points to do your modeling. So we have a series of tools. One of them that's very useful is called Sample. And what Sample allows us to do is reduce the size of this point cloud. So if we wanted to reduce it by about 80%, in other words, keeping only about 20% of the original, when we press the green check mark up here, you'll see that it does a good job of reducing the size and complexity of that point cloud while keeping detail in the key areas like the edges. Now, for our purposes, we don't necessarily need to go that extreme. We'll just choose to reduce the file size by a factor of 2. So we'll just reduce it in half. Pick our cloud, hit the button, and it'll reduce that cloud down to about 50%. So we'll move forward with about 200,000 points. So that's just a good way of keeping the point cloud size in check, which will speed up the processing as you go downstream. Now, the next thing we need to do is we need to actually convert this point cloud into a mesh. So you could, in theory, start extracting surfaces, but it's a lot easier if you have a mesh body that you can see and interact with. So, again, one of the core competencies of Geomagic has long been the ability to convert any point cloud into a mesh object. So what this command does is it connects the dots. Okay? So if we were to zoom in here, you'll see we can turn on the display of the edges. Essentially what we just did is we took all those individual points and we connected the dots to create a series of polygons or triangles that are all connected together. So this is what we call a mesh. So you'll hear that term mentioned quite a bit. Now once we have the mesh, we could, if we wanted, start to do some things like filling in holes, for example. Now, again, it's not required, it's optional, and it's really not needed in this case. We have enough to extrapolate everything that we need. Obviously, because of line of sight, most scanners, specifically like the one used here, cannot see deep into holes. So a lot of this, the reason why you marry scan data processing with CAD tools is because that extrapolation of the missing geometry is what CAD does very well. That's the creation and extension of existing boundaries to create long internal components. So there's actually a lot of kind of ductwork, I'll call it, on the inside of this part where some of these things connect. And you can do all that in the CAD package. We're just going to get and kind of extract the outer portions that we can see, and we would do the rest later. So one thing we'll do is we're going to go ahead now and start the modeling. So what we do is we click on this object, the tree, and we just choose to transfer it within the same application, but we're kind of throwing it over the wall so that the space claim tools are aware of it, and it just changes color. And now we're able to use tools like pull and move and combine to start extracting geometry. Now, one thing that we need to do first is if you look at this, relative to that coordinate system right in the middle, the part is not oriented. So any CAD designer would tell you I wouldn't start designing a part that's on such a kind of a cockeyed orientation. So if we look at the current side view, you can see that my mesh is tilted with respect to my coordinate system. And that's very common when you scan something. You don't really pay attention to or care about its orientation. So one tool that we've developed to help this is a single one-button orient mesh command. Now this is kind of this is a neat new thing that was introduced with Design Direct 2014 just a month or two ago. And what it is, it's right now the software is looking at this object and it's looking for planes, cylinders, cones, anything that it can resolve into a plane or an axis. And then it uses that combination of planes and axes and it looks for trends. So it says, okay, if we have a lot of planes that are pointing in one direction, maybe that should be X. If we have a bunch that are orthogonal to that in another direction, then we should orient that to Y and so on. And then more so than that, it also looks for large cylindrical features that it can then define as being the central axis. So what you'll see now is it just updates the screen and it kind of automatically orients itself, and you can see all of these candidate planes that it found on the shape. And again, just while I was talking, I wasn't doing anything. It was searching the part to find these candidate planes and axes, and then it does an orientation. And it looks like it did a pretty good job. I would agree that that's a pretty good way to set up the coordinate system for this part, is to have it where the XYZ is right in the center at the bottom surface. So that's what we'll choose. So we're going to just hit select. All those planes and axes were just temporary. I chose not to keep them. So what we're going to do now is go in and start working on extracting some solids from this. Again, we still just have a mesh. We've got to create a solid. So one thing we've done is we've got some technology that helps us do that by doing what we call detect regions. So region detection is where, similar to what it just did, it's looking for things like extrusions and revolved shapes. It's looking for flat planes, and it's looking for cylinders. And what it does is it will color the mesh to help me out. And this will help me define and pick out areas that are contiguous planes or contiguous cylinders, and it makes the selection easy. So you'll see there it changes color. It basically highlights the edges as kind of a dark purple color. And what I can do is I can actually turn on region coloring, and I get this nice set of pastel colors, and that's just a visual cue that makes it even easier to see what I'm doing. So one example of how this works is, let's say I look at this slot on the side over here. It's kind of a rectangular cutout. I go to our extrude tool. I can click on this region right here at the bottom. It's going to kind of turn red. And then I click this expansion button. And what it does is it kind of searches, and it goes and it knows to kind of trace around the inside. And with one click, it finds this kind of a nice little slot. And then if I click the green check mark, it'll build that solid. And if I hide the mesh, you'll see what it did. So a couple of clicks, and it just automatically, with one click of a region, it said, let me go find any other regions that neighbor it that I think might form an extrusion. And that's what it found. All right, so we can do it again another way. Let's just say we want to pick these outer regions here. And what I'm going to do here is just turn off the colors to make it easier for you to see. So if I just pick, holding down the Shift key and picking these outer regions, and then I can have it actually kind of search and look for any other kind of candidate regions in there. And then what it's going to do is you'll see a preview in a few seconds. It's like a black line that will indicate what my regions are. So you can kind of see it's like a preliminary sketch. You can kind of vaguely see that black line going around the outside, such that if I were to hit the complete button, it'll build the solid. Okay? So just by a couple of quick clicks on these regions, you can start to quickly create the solid. Now we're going to step out of one of the Geomagic tools and use one of the native SOLIDWORKS tools, in fact, probably their star tool, which is called Pull. And what Pull does is this direct modeling at its kind of most essential. It's the ability to click and drag on a face. And with the little bit of latency in the webinar, it won't be quite real time. It's much more fluid when you're not doing it over the web. But what you can do is move that face, and more importantly, what I can do is I can choose to move that face up to any picked point. So I'm going to actually pick on a point here on the mesh, and it's actually going to move that surface up to that picked point on the mesh, and that guarantees then that my solid is the same size as the underlying mesh. We'll do the same thing on the bottom. We're going to move this up. Again, you can kind of eyeball it, or you can pick a point on the mesh, bottom of the mesh, or what might be wise is to actually do it. In this case, I'm going to measure it. I want to do it so that it's perfectly offset from that top surface. So I click and it says, well, currently it's 74.992. Well, guess what? I'm pretty certain the design intent was to be 75 millimeters. It's probably how this machine block was created. So it's not just it's an exact science. You can actually move these up to a point that you want, or you can actually key in values. You get the choice either way. It's one of the misnomers with direct modeling is people think that it's not, therefore, parametric. It isn't very much parametric. It's just not a feature tree. There's not a history tree. If you look on the left, when we get created, we have a single solid. There's not an attached sketch with that. So now what you can do is you can do things like you can take this face, you can kind of push it in to create that little pocket. And again, same thing. You can take that face, you can choose to pull it exactly up to that surface to be flush. Let's take a look at this little cutout here. So we have this side surface. Maybe what we're going to do is kind of cut off that corner. So all we got to do is click the plane tool, click this region. And in fact, you can already see a little preview of the plane that it's going to create. It gets created. We show our solid. We'll use the nice combine tool to just kind of carve away that piece right there. Let's do the same thing again here. Here we're going to do it slightly different. So what I'm going to do is I'm going to hide these regions, and we'll use the extrude tool. But rather than using the region selection, I'm going to show you something that's kind of nice. There's a really nice way of just clicking and dragging using the mouse to vary the amount of curvature that's selected. We call this Smart Select. Smart Select is a very handy tool for just quickly selecting contiguous areas of the mesh. The other thing I'm going to show you is that I can constrain the extrusion direction. So here, there's some inherent snapping where if it's close enough to the Z direction for the extrusion, it'll snap to it. But just to force it, to really force the issue, I want to make sure that that extrusion direction is in fact in the Z direction. So here now, it creates that little solid, but you notice, see, it doesn't know to kind of cap that off. That's pretty understandable. So what I'm going to do is I'm just going to oversize this guy by just kind of pulling it out. And then I'm going to take this face and pull it up a little bit. And then all we're going to do is we go back, we turn back on the main body here, and just do a little carving away, and then go back to that pull tool and just maybe again move it down. Just use that nice pull up to feature so that it's right there, right where it's supposed to be. And then let's do maybe one more on this piece before we flip over to another part. Let's do this interior body. So we're going to do this as a rotational. So I could do it as two concentric cylinders if I wanted. Here what I'm going to do though is we're going to actually use we're going to kind of pick these regions on the inside. We have some nice little tools to kind of optimize that selection to make sure you're not picking up unwanted geometry. And we're going to create this little plug almost. Okay, you kind of see this little body here. And then again, we'll use our combine tool to subtract that body from the inside. All right, so we have that little cylinder there. And then maybe if we want, we can turn on the mesh again, and you can use, let's say, the cylinder tool. And we'll click on that region there. You can see that it'll give you a little preview of that cylinder. You can oversize it, create a little cylinder. And then what's nice is you can also create a pattern. So we can choose that cylinder and quickly create a cylindrical pattern. Choose the axis of rotation, the Z. There's 8 of them. And so you can create that little pattern there, which you can then use to go and Boolean out of that solid. And so you go through this process and you just kind of work your way through it, extracting geometry and extracting features. So we're going to leave this part for a second. We're going to open up another one that's got a little bit kind of more complicated case. This is a little bit more truer example of reverse engineering. You've got a little roller cage or a gear, and you want to reverse engineer it, but you only have partial scan data. Maybe it was in a clamp, and it was hard to see what the rest of the shape was. But because it's a repeating pattern, you don't necessarily need the entire thing scanned. So we'll start here. You could start a couple different ways with modeling this body. What I'll do is I'll start by just creating basically a conical shape on the outside. Now, I alluded to before something called Smart Select. Smart Select allows me to click and just drag up or down on the screen, and it will vary in real time what the selection set is. So because I have it on a cone, you can see if I just give it this amount of data, that's not nearly enough to extract that large outer cone. So I hold down Shift, I give it a little bit more data, starts to refit, and slowly I'll start getting the cone shape I want, because again, these are just little slivers of data that define this outside cone. And the other thing I can do is help it out by giving it the rotational direction. So eventually you kind of see there that kind of ghosted shape. It's kind of showing me I'm slowly kind of defining it. And it's probably a little bit of overkill if I keep adding, more on the side. So I just go ahead and click the complete button, and I've got kind of an oversized cone. Now what I can do is go ahead and use the pull tool, just like we've seen, and I can pull down, and then I can use the nice up to kind of get it centered. I may want to actually fit a plane to that top surface to get it more exact rather than just picking a single mesh point. That's up to you. You can certainly do that. And we'll pull it up just a little bit to create the right size. Now, we're going to hide that cone, and we're going to use our Revolve extraction tool. Again using Smart Select. So you'll see here if I click and drag down, it propagates that selection, but just the really planar areas. But as I drag up, it'll start to actually creep up the sides of that inside portion. And if I wait a few seconds, I start to get a preview of what the sketch looks like. It's always a good idea to use what we call optimized selection. Optimized selection is a nice way of kind of infilling that portion. Now, the other thing that we can do is we can also, again, we're going to lock the constraint so that the axis of rotation is, again, the Z-axis. That makes sure that we're concentric with that cone on the outside. Now, if we want, we can choose to not just create a solid, but actually go and create a sketch. Now, here's one of the powerful things about SpaceClaim, is it has some really nice embedded tools for dealing with mesh data, where it puts it into a nice cross-section mode where you're seeing a cross-section right through that mesh overlaid with your scan data. And what this allows me to do is, I can see here that in the fitting, it created this little kind of extra circle, and I don't want that little extra bit right there. Okay? So what I might want to do then is just take this line, extend it up, and you can see how it'll snap to that original trajectory. So that way I know it's not kind of going too far. Same thing here. What I might want to do is extend this line, and it keeps it on that trajectory. And I might want to kind of snap it to this line. Okay? So you don't have to just create sketches in solids directly. You can kind of take a stopover at the sketch phase and add or change the extracted sketch profiles. And then when you're ready, you just go back to the pull tool, and what you can do is you double-click this line, and we're going to hold down the Alt key. We're going to click that axis, and you can kind of drag that guy around the outside. Oops. We're going to define our axis of rotation, and we'll do what's called a full pull. Oops, I got to pick the lines, of course. There it goes. And it's going to whip itself around. Again, it's a little slow on the webinar. You can't see it. It's animated in real time. And it just does a nice little animation of actually rotating that curve around that axis to create that little rotated body. And then what we'll do is we'll take our cone, go to our combine tool, pick that inside surface. Oops, got to do it in the right order. Sorry, hang on one second. Well, I did something wrong. I was unable to intersect them. I think what we got is might have a hole in that surface there. So what we'll do is let's delete that, and we'll just try it again. Delete our surface there. Let's go back into revolve, whip it up, and this time we'll just create the solid. So we'll choose as our axis of rotation this guy, create the surface. And again, if you don't want to, if it can't create a surface, a solid, it'll just create a surface. So here we'll go in, we'll click, and we'll delete that little kind of curly cue there. And another nice tool is if you do have a hole, you just click on it and hit F, it'll fill it in. And the other thing too is to overextend, rather than doing it in the sketch, I can just do it this way. So what this allows you to do is you can kind of quickly go in and create new geometry and modify geometry in just a matter of a few clicks. All right, a couple more things we'll show on this. So here what we want to do is we want to extract a couple of these little teeth. So we're going to create, we'll just pick one as kind of a good candidate cylinder. So again, using that smart selection, you can see I can vary how much or how little is selected. And I get a nice preview of the little cylinder body. And we'll say, yep, that looks good. We might use optimized selection is always good to kind of get rid of outliers. And it creates that little cylinder body. And then what we're going to do is create a pattern. So we're going to go to the pattern tool. We're going to click on the cylinder. We're going to click the axis here, the central axis. And in this case, I happen to know we need 20 of them. So we type in 20, and it creates those bodies. And then when we bring this, our cone feature back, it's just a matter of going to the combine tool and choosing to subtract that. And then one thing you could do is you could just walk around, and it's very graphical. You can just pick the pieces that you want to subtract. If you didn't want to do that, you could, of course, just come over here and multi-select these pieces in your tree and just delete them that way. So essentially now you have kind of the makings of your gear, but there's one other thing that's very interesting, which is there's this kind of shallow indentation in the middle. Now, we could go to our extract tool, and we could use a tool like Smart Select, and we could try and see if it's able to actually find that geometry. And it is. You can see there that it actually does a pretty decent job of finding that little plug, that little extruded body. Just a couple of quick clicks, and I got it. Now, and that's fine, but for this demonstration, what I want to do is show you another nice feature of this product, and that's the ability to just sketch over top of the mesh. So what we're going to do is actually put it into like a top-down view here, and looking right down on it, we're going to go into sketch mode. And when you go into sketch mode, as I alluded to before, it actually does a nice cross-section right through the mesh. And what I'm going to do is I'm going to move it up just a little bit, and you can kind of place this plane, this cut plane, wherever you want. We're going to put it right here. And then we'll put it into a nice plan view, and we'll use the sketch tools. In this case, I'm going to create, I know that this outside is just a simple arc that radiates right from the center. So I'm going to use a tool that lets me pick the center point, and then pick points, and you'll note that it will actually snap to the underlying mesh, which is very, very handy. And then we'll create a couple of quick lines. Again, you can notice how that little green ball indicates it's snapping to the underlying mesh. In fact, if we hide the mesh, you can see that. And what we can do here is if I use our select tool, you can actually really quickly just drag cursor over it. It selects those two line ends, and then hit the F key, which is fill, and it'll fill those in. And then another nice feature is if we go to our radius tool, you just click this corner, you can drag it in, and it'll actually snap, as you can kind of see there. It's almost like a little force field. It's snapping to that underlying mesh. And I can repeat that on all four corners, and it will snap to the mesh. And you may want to actually specify a radius. That's probably what I would do, but just for time's sake, I'll just snap it to the underlying radius, or the underlying mesh. And then I just create this little body, just kind of pull it up to oversize it, and then turn on the solid. Maybe we'll create a pattern first. We're going to pattern this body around the axis. We're going to create not 20 of them. That looks crazy. We want 4. and then we use the same combine tool we used before to just punch out those 4 little kidney shapes. So we're almost there, almost to the end. We've got our little kind of gear body. We didn't define the middle portion, but what we're going to do now is let's go create a drawing. So I'm going to go to File, New, Drawing Sheet, and it creates a drawing sheet, but it also does a little bit of the work for me. When you create a new drawing sheet, it automatically populates the 3 views. And I'm all ready, ready to go, ready to create some dimensions. And I use a nice dimension tool. You just click these lines. So if you click one line, it'll dimension that. If you click another one, it does a relative dimension between those two. I wanted to do, it's a smart dimension tool, so depending on the entity you pick, whether it's an arc or a line, it'll apply the right radius to it. So you can go around here, you can dimension your drawing, put your values on it. What I like to do too is you can go to this general view. You can place like an isometric view wherever you want. You can choose to link that to it. What's very handy is that you can also choose to show other geometry in this view. So maybe I want to show the mesh here. So I can show views of the solid. I can also put ISO views of perhaps just a mesh. I can show inset views, detail views. You know, if I wanted to come in here and show like a little inset detail view and put it right here, and then maybe I need to scooch over this view, I can do that as well. So it's a very nice, very handy detailing and dimensioning tool and drawing tool. So this is all based on, everything I've shown so far is predicated on scanned data. But I want to show off now some new capabilities that we recently added. So back to the window for a second. You can see here in this set of capture tools, in fact, let's go all the way back to this one. You'll see in our capture tool, there's a set of tools called Acquire. And in the Acquire tool, there's something called Connect. And what's Connect is it allows me to connect to a device. It could be a hexagon arm, a Faro arm. It could be a Nikon measurement arm or some other devices and collect data in real time. And so we've been slowly adding some new tools for creating not just basic primitive features, but also sketches. So because it's difficult to try to work in an actual probing arm during a live demo, what I've got is a little pre-recorded video I'll show you to kind of explain how the process works. So you see here, we happen to, in this particular video, we use a Faro arm, but again, hexagon, Nikon, Iridium, the process is all the same. We develop these connections to these hardware devices. So here, we're actually doing what's called a probe sketch. So as the user is walking around the part, probing the profile of that same, there's that silver part that you see clamped to that table. That's the same part that I had scan data of that I showed earlier. So this is an example of creating a model, but only with probe information, not with any scan data. So the user simply creates a series of planes, cylinders, cones, spheres, whatever happens to be on there, but you can also create sketches. So even though this part is very boxy and prismatic, you can, it doesn't matter. You can create very complex sketch shapes by simply tracing around, sort of as you see the user doing here. He's creating that little kind of a U-shaped channel. And there's connectivity between the entities. So as you go from one entity to the next, you can choose whether it's a tangent connection or a non-tangent connection. There's also inherent smart snapping, where it will snap to existing X, Y, and Z coordinates. It also tries to maintain parallel and perpendicular relationships. So it's more than just creating lines in a free-form fashion. There's a lot of engineering thought giving to this, knowing that people will be creating a lot of concentric, parallel, and perpendicular shapes. So here's an example where the user created a simple sketch of the square, and then they're going to go in and start creating the solid geometry after he's put the arm down. So at this point, he's collected all the information with the probe, and now it's just time to do what you saw me do before, which is simply convert those curves into solids or surfaces and start Booleaning or combining to subtract pieces or add pieces to it. So again, you take the sketch geometry, you can add a little more to it. You can use the intuitive snapping and cutting and sketching tools to kind of repair and complete sketches if you didn't do the whole thing, because a lot of the sketching tools that are very, very nice, very intuitive in SpaceClaim are right there at your fingertips to be able to use. And so we leverage those tools quite a bit. Here's a good example of these little cutouts where after they're created, because they weren't created tall enough, they don't completely intersect, but it's really easy to take that face and do what's called a pull, where you just pull it right through that face. Again, that's one of the nice advantages of direct modeling, is that really quick and easy to just click and interact with faces on the model without having to do a lot of digging through the feature tree to find that particular sketch or feature in the tree. I did see one of the questions in the webinar was, can you connect the tool to a laser scanner? Absolutely. Those same tools I mentioned, the Faro laser scanner, Hexagon has a series of them, Nikon has a couple of different models. We were allowed to kind of scan directly in. There's also a scanner by a company called Violux that we can have a direct interface to, and we will be implementing or producing an SDK to allow other companies to integrate very shortly. So we want to promote and foster integration with other scanning devices. It's just a matter of time as we put the SDK out there to let the companies develop against it.